Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier, question number 6 from 2023. This question is on the topic of electricity, which is actually the required practical. A student investigated how the current in a filament lamp varies with the potential difference across the filament lamp. Now you should recognize the shape of this graph. Figure 6 shows the results. So the graph shows how the potential difference varies with the current when you change the potential difference in a filament lamp. Now this is a typical shape for the filament lamp. Now you should also remember there's two other graph shapes that you should remember. So if the graph is a straight line like this, or you could, if it's a straight line going through like this, these two graphs is for a resistor. Right, let me get rid of the logo for a second. So there you go. So now if the shape for the diode is basically like this. So if I draw for a diode, it's basically the shape is going to be like that. This is for a diode. Now let's have a look at the rest of the question. Describe a method the student could use to obtain these results. You should include a circuit diagram. This is a 6-mark question. So let's start with the circuit diagram. How do you measure the potential difference? Now, because the potential difference according to the graph is on the x-axis, this is the independent variable. Now, because the current is on the y-axis, this is the dependent variable. So you're going to change the potential difference, and it looks like they've changed the potential difference from 0 to 2 to 4 and then 6, and they've gone on the negative side as well, -2, -4 and -6, right? And they have in fact got values for every 1 volt, because you've got points for each of the volts, both on the positive and on the negative side. By changing the potential difference, they've recorded the current in the filament lamp. So in order to measure the current in a circuit, you will need a ammeter. In order to measure the potential difference, you will need a voltmeter. Obviously you need a filament lamp, a power supply, and in order to change the potential difference, you would need a variable resistor. So these are the equipments that you would need. So how do you connect all of this? So let's start with the power supply, which is going to be a cell, and to that we are going to connect an ammeter in series, and then to the ammeter we are going to connect a light filament lamp or a bulb, and then we are going to have a variable resistor. Let's make sure that's connected now. And how are you going to connect the voltmeter? The voltmeter needs to be connected in parallel to the filament lamp, and you're going to change the potential difference across the bulb by changing the or adjusting the variable resistor. So that's your variable resistor. DC power supply, voltmeter, filament lamp or lamp, and an ammeter. Now you set it up as shown in the circuit. Now you'll have to describe the method. Now if you draw the circuit properly with the labels, then you can avoid describing how to actually set it up. So your first step can simply be, you can start off by saying set up the circuit as shown in the diagram above. Then you would adjust the variable resistor to 1 volt and adjust the variable resistor so that the voltmeter shows 1 volt across the lamp, and then measure the current in the ammeter. Then adjust the variable resistor again so that the voltmeter reading changes to 2 volts and record the current again. And you do that up to 6 volts. Once you finish it up to 6 volts, what you do is swap the polarity of the cells here. So this is your positive side and then next the negative side, and you swap the power supply wires or the polarity, and your voltmeter reading and the ammeter reading will be negative now. Then you redo the same adjustments in the variable resistor starting at -1 going to all the way down to -6, and you record it in a suitable table which could look like this. So the voltage, which is the PD, and the current, which is the measured in amps, and you would go 1, 2, 3, 4, 5, 6, and you put that at 0, and then -1, -2, all the way up to -6, and record the ammeter. So this is what the marking scheme is actually looking for, and you could describe it in your own way. Right. In the marking scheme, they're looking for, is there evidence of an ammeter connected in series with the filament lamp? Yes, we have. And we need to indicate that the current is measured with an ammeter. The voltmeter should be parallel with the filament lamp, and the potential difference is measured with the voltmeter. Variable resistor, right, is used to vary the current and potential difference across the filament lamp. The range of potential difference should be from 0 to 6 volts because that's what the graph says, in intervals of PD of 1 volt because it's going from every other volt. And reverse the connections to the power supply to obtain the negative values. And you need to mention that you need to take repeat readings and calculate a mean, and that's important, which I didn't mention it at the start. So this is something that you would want to mention separately in the explanation. Discard anomalies and indicate, right? Discard anomalies, right? The main reason you are repeating readings is to discard any anomalies, and then you calculate the mean. When you're calculating the mean, you don't include the anomalies. Now this part, indicate content may be seen in a circuit diagram. So most of this can be seen in the circuit diagram. So if you draw a proper circuit diagram, then you can avoid writing at least half of these sentences. To get a level 3 answer, you need, or it says it needs to include a circuit which would work if included, and a method to obtain the negative values. And it's an easy 6-mark question. It's not really hard if you remember the diagram properly and you remember the basic steps. Question 6.2. Determine the resistance of the filament lamp, which is capital R, when the potential difference, which is V, across it when is +3 volts. Use the physics equation sheet. Use figure 6. So what is the link between the potential difference, current and resistance, the equation is V equals IR. Now, we know the potential difference is 3 volts. The current is, you need to find the current from the graph, and resistance is what we are trying to find. So let's look at the graph again. What is the current when the potential difference is 3 volts? So when it's 3 volts, which is here, the current is over here, and that's just one box above, which is over here. So 5 boxes are 0.05. So 0.05 divided by 5 gives me 0.01. That means if I add 0.01 to 0.1615, this value is 0.16 volts when the potential difference is 3 volts. The current is 0.16 multiplied by the resistance. Rearranging the equation, R equals 3 divided by 0.16, and that gives me 18.75 ohms. 18.75. Next part, the current in the lamp is 0.21 amps. So that's the current. It's always a good idea to write the symbols. That way you can automatically use the equations really easily. When the potential difference across the lamp is 6 volts, that's the voltage, that's 6. Calculate the energy transferred, which is E, by the filament lamp in 30 minutes. That is going to be my time. So I've got E, I, V, and T. So they're asking me to calculate the energy. So what is there's no one equation which links all three of them. Actually, there might be, right? Now there's a couple of equations that you can use. The first equation that you can use, which is just one single equation, E equals V, I, and T. Energy equals the potential difference multiplied by the current times the time. Now the time needs to be in seconds. So 30 minutes multiplied by 60 should give me 1,800 seconds. That gives me 1 mark out of the 5 marks. Now, in this 5 mark question, if the final answer alone without any working will give you just the 5 marks. But I would show the steps just to make sure that you're not missing anything. So the voltage is 6 multiplied by the current is 0.21 multiplied by 1,800. So let's bring in the calculator for this. So 6 times 0.21 times 1,800, that gives me 2,268 joules. And that's the 5 marks. Now, if you don't have this equation in the equation sheet, right, because they're asking you to use the equation sheet. If you don't have it, now it's worthwhile checking that across. There's another way of doing this as well, right? So let me show you the marking scheme, the way they actually accept the answer. So here they're giving you a mark for the time, and then they're using Q equals I T, right? This equation, Q equals I T. They're finding the charge, which is 378 coulombs, and then they are using E equals IV to find the energy. Or you could use the equation that links power, P equals IV. So that's the current and the voltage. Once you find the power, then you can use the equation power equals energy divided by the time. Rearrange it. Energy equals PT. Next question. The power output of the lamp is 1 watt. So the power output is 1 watt. That's the power. When the potential difference across the lamp is 5 volts. A student predicts that the power output will be 4 if the potential difference was doubled. Now, explain why the student is not correct. Now, this is a challenging question for 2 marks, and the best way to approach this is actually to work it out using the equation. Now, what is the equation that links PI and was the third variable? This is the current. So the equation that links power, current and voltage is P equals VI or IV. So let's apply that statement over here. If power equals P equals IV, right? 1 watt is equal to, now we don't know the current. They're saying when the power is voltage is 5 volts. So when it's 5 volts and if the power is 1 watt, the current has to be 0.2, right, in order to satisfy this equation. What they're saying is, if they double it from 5 volts to 10 volts, will the power be 4 watts? Now, for that to happen, the current should double from 0.2 to 0.4. Does that happen? When you double the potential difference, does the current also double? Now, if they behave like that, then this would be correct. Then the student would be correct. But they're saying the student is not correct. Now, the reason the student is not correct is if you look at the graph, right, it's not a straight line going through 0, right? If it was a straight line going through 0, then you could say, right, then you could say the potential difference and the current is directly proportional. So that's I and V. Now, if the graph was a straight line like this, then that would be correct. But the graph is not a straight line. It's actually an S-shaped graph, which is basically going like that. So when the potential difference is actually increasing, the current is not actually doubling. In fact, the current is actually reducing. Why? Because the resistance increases here. That's the reason the current, the power is not going to be 4 watts or quadruple. So it's not going, the power is not going to move from 1 watt to 4 watts. So we are talking about by quadrupling here, right? Increasing by a factor of 4 if you double the potential difference. For the potential difference to for the power to quadruple, the potential difference, if you double the potential difference, the current should also double for that to happen. Right. Here's a answer that you can write down. For the power to quadruple, which is basically from 1 watt to 4 watt, according to the question, the current and the potential difference would both need to double. But the current doesn't double because the resistance of the filament lamp increases. That would give you the 2 marks. Or you could say, but the current doesn't double because the graph shows that the current is not proportional to potential difference because it's not a straight line. That brings us to the end of this question, and I will see you in the next question.